Lab 3. The experiment is the purpose of the experiment is to calculate the mass of black hole. dp over dt refers to the rate of change in momentum, denoted here by vector p, which can be written by its magnitude times its unit vector. We can use this fact when taking derivative of p and apply product rule for differentiation to this formula. By Newton's second law of momentum, F net is equal to dp over dt, so apparently the two terms in the equation are simply the parallel and the perpendicular components of dp over dt. Since dp dt is equal to F net, we can simply write dp dt parallel equal to the F net parallel, dp dt perpendicular equals to the F net perpendicular. Since F net is equal to the rate of change in momentum, the magnitude of F net is equal to the magnitude of dp over dt. The assumption we make on this slide is that the only force acting on the star is the force due to gravity exerted by the black hole. Now moving on to the computational model, the initial condition of the star's mass is set to 2 times 10 to the 30th, and the delta T is set to be 86,400, the number of seconds in a day. Here I will explain how I apply Newton's second law to my model. First, I pull the velocity data from the x-val and y-val. Then I define the initial momentum and final momentum. After that, I found changing velocity and changing momentum respectively. I then defined dp over dt and set F net equals to it according to the Newton's second law. And finally, I used some simple vector calculations to find the parallel and perpendicular components of F net. To calculate the mass of the black hole, I applied the formula obtained by using the Newton's universal law of gravitation. I created a variable called sum mass and incremented it as time goes, and at the end I found the mass of black hole by calculating the average. Here is a screenshot of the programming action. The data printed during the programming action is presented here. I graphed the magnitude of the overall magnitude of F net against time, as well as each magnitude component of the F net against time. In order to avoid the discrepancy in F net parallel, one can use a computer with more powerful processor. There is mathematically no difference between the net force and its parallel and perpendicular components and the rate of change of momentum and its parallel and perpendicular components. The main difference between the two in this experiment is that dp over dt can be calculated directly using the star's position, velocity, and momentum as function of time, whereas the net force is not something we can calculate without actually knowing the mass of the black hole. To calculate the velocity that the spaceship needs to have to enter the orbit, one can use the formula that the perpendicular net force is equal to mv squared over r, and the perpendicular component of the net force can be calculated by the perpendicular momentum of rate of change in momentum. Thank you for watching.